Okay, sounds good. I think the recording has started. Let's begin. Hello, folks. My name is Arjuna Chella. I represent LexisNexis Risk Solutions, especially the HPCC Systems Organization for Big Data Analytics. Now, I'm not sure if any of you have seen the video. I'm pretty much going to repeat the content of the video, but the biggest difference is going to be that it's going to be interactive. I hope that now you can stop me and ask questions whenever you feel like there's something that needs to be clarified. Again, welcome to the 2021 edition of the KSU Hackathon. The challenge for you this time around is, I think, very, very interesting. We are trying to solve something that is a social cause, obviously, but it's something that's very close to our hearts as far as the LexisNexis audience is concerned. We have been working on concepts of this particular program for the past 15 to 20 years, working with many government organizations across the board to see how we can recover missing children safely and as quickly as possible. So in essence, the challenge revolves around enhancing this experience, the experience that we already have in place, but enhancing it so that we can provide law enforcement and people who are working to recover these childs much more quickly and effectively. Yeah. Sorry, I think I skipped over a slide. Okay, now before we dive into the actual use case, I think many of you who probably have been to our hackathons before have seen this slide. I made a little bit of adjustments on this slide so that I can explain some of the use cases straight away and then come to describe how these use cases are achieved. Let me start from the right-hand side here. For me, it's the financial services, the government, healthcare, and insurance verticals that we work with. So if you want to open a bank account, for example, the bank wants to know whom they're working with. So they ask LexisNexis the question, can I depend on this person to open a bank account and then be a dependable customer, right, without causing any fraudulent actions that the bank will not be able to process their transactions with, right? From the government perspective, we work with the government on several fraud-related issues, and most of these frauds are developed by complex social network engineered networks where many people are involved, and it is very hard to find who's the real ringleader in this fraud scenario, right? So that's in many cases what we work with the government revolves around socially engineered fraud. Okay. And then another use case more related to healthcare would be if you go and fill in a prescription at Walgreens, they want to know you're doing it for the right reason, right? So if you are Y-coding, we want to make sure that you really have a disability that you need Y-coding for, right? And so it's not that you're going to get the prescription and then upsell this drug to somebody else. So those are the things. We want to verify your background to make sure you're the real person who you claim to be, and then you're doing it for the right reasons. Similarly, on the insurance side, we want to provide the insurance companies the best risk assessment of an individual so that when they provide you premiums for car insurance, for example, they know the background of you as an individual in the sense, how much risk do you take on the road, how many speeding tickets do you have, and all these details, bring it together and then come up with a risk assessment of you for the insurance company. So that, in a sense, is our core business and business verticals. But how does all this work is by LexisNexis Risk Solutions, collecting data from several sources. One of the major sources is public records. In public records, domain, examples would be court records, criminal registries, and so forth, right? And we have state agencies where we collect driver's information, your DMV records, your accident records, police records, and such. And then we have contributors who provide us the data with regard to, for example, insurance policy, claims, telematics, and so forth. So what we do is we take all this data and bring it together in a technology called HPCC systems. As you can imagine, it's not a trivial exercise by any stretch of imagination. Now we collect multiple sources of data, 10,000 sources that we go after every day, and bring it all together so that somebody who does a search on the right-hand side in the financial services sector or government sector, they have the latest and greatest information almost instantaneously. Right? Any questions so far? Let me just check the chat here. No questions so far, I think. Okay. Let me keep moving on. So why KSU? Well, we are fantastic partners. We've been working with KSU for 4 years now, and one of the things that we realized very earlier on was, that the KSU management knew a lot more about what the industry needs compared to many other peers in the university world, right? So that is what we liked about KSU right from the get-go. In the sense, the folks at KSU knew that the industry was looking for this level of collaboration to be successful with their students. Professor Don Tatum, Dr. John Preston, and Dr. Jeff Chastain and Adriana Clark have been working a lot to make all this happen behind the scenes. And they've worked through the year for these hackathon type of events to come together. Obviously, they do more than just the hackathon, but I think the way they strategize and bring all this together makes it very easy for us to develop solutions around universities. Okay. Then, yes, fantastic partners are great, but we also need fantastic students. One example was Vanel Sofiak, who has been interning with us for a couple of years, and he just graduated. He graduated, I think, this spring semester. He was looking for a job. He had interviews in LexisNexis, and for whatever reason, it did not work out for him in LexisNexis. But we took him and introduced him to one of our partners called Data Sears, and Data Sears loved him. So he's one of the success stories who started this week at Data Sears, and a very hardworking student, 3.8 GPA, 4.8 GPA, 4.0 GPA. So, and every time I interact with him, he's in the lab working hard, looking at concepts, coming back to us with questions and collaborating. And those are the types of students we encourage and we want to participate in any collaboration that we do. And that's why we love working with KSU. Last but not least, we have fantastic alum from KSU. Trish McCall, who's the HPCC System Director of Program. She's also the Adam Program Leader. She has been with LexisNexis Risk for over 30 years. So fantastic person, again, graduate of KSU. And Professor Bahar Fardanian, who's teaching HPCC data analytics class currently in KSU. And she's been with LexisNexis for over 10 years now. And again, great students who come out of KSU, become our employees, and become great contributors in the long run. So let's switch to the program itself. Let's talk a little bit about the actual challenge. And before I dive into the actual challenge, I want to talk about the current program that we have in place called the ADAM program. Okay, what is the ADAM program? So when so one of the things that we do is we work very closely with the National Center for Missing and Exploited Children, and they have a database of all the children that are missing at any point in time. And you'll see in the next slide how that workflow works with some of the solutions that we provide. But some of the statistics that they come out with is really stunning, right? So in 2020, for example, NECMEC, assisted law enforcement and families were, more than 29,000 cases of missing children. So that's mind-blowing. All of these 29,000 are missing children. 91% were runaways, right? They just ran away from home for whatever reason and farm. That is potentially a solution that we want to attack as well, but not probably for this challenge. And 5% of the family were abductions. That means they were abducted by a family member who was a close relative. 3% of them were critically missing young adults between the ages of 18 to 20. Less than 1% were non-family abductions. An example of that was the unfortunate event that happened the day before yesterday, I think. Yeah, it was the day before yesterday in DeKalb County, in that close to the Atlanta area, where robbers were robbing a house. Actually, also kidnapped this little girl from the house, and so sometimes non-family members. So that's 1% of them are the culprits in kidnapping missing children. And last but not least, 1% of this law are just lost. They're playing out there. They've gone out for something and they just get lost. Right? Again, another unfortunate statistics. But for this challenge, what we are really worried about is this stat, right? Where over 26,000 runaways reported by NECMEC in 2020. 1 in 6 were likely victims of child sex trafficking. That's a huge number to consider the number of abductions that are taking place. So our challenge really revolves around how do we create a solution to see if we can ask law enforcement to take actions that are very critical, so that we can reduce this number, if not eliminate this number, if we can, right? So that is the key stat out there. Now, going back to the state as of today, when we go and look at our ADAM program database, we have about 1,600 active missing children as of today, and that's a mind-blowing number again. It's just something that has to be reduced somehow or the other. And imagine how many of these children, based on the previous data I showed you, how many of these children are potentially exposed to sexual offenders. We want to reduce that number as much as possible. Okay? Going back to the ADAM program, this is how it works. Okay, a child goes missing. The law enforcement is informed about the nature of the child going missing, and then law enforcement informs the NECMEC organization. And the NECMEC organization obviously collects some critical information about the child, the whereabouts, the age, the general outlook of the child, a photograph, if they can get to a photograph, and then they send that information to us, which is the ADAM program. Okay. And what we do is in the ADAM program, we look at the location where the child went missing, and based on the location and some more specifics about the location and how the child went missing. We triangulate all the people that needs to be informed in and around that region and send out alerts to these people so that they can then see the posters and act on this. If they see this child, let's say a child comes and visits a restaurant, and the restaurant workers have seen the poster, they'll be then able to say, hey, now this child is in the restaurant, and call 911. So that's an example of how it actually works. So I'll pause there a little bit, and again, look at any questions that you might have. Again, if you have any questions, feel free to ask straight away here. If not, you can also message us those questions. Okay, there's some questions, but I think this is more related to the technology itself, and I think Bahar is answering most, if not all, those questions. So, yeah, okay. So I'm going to continue. So this is an example of the information that we collect about the child, and that is sent to the outside world, right? So if we find parties that need to be informed that can act on this message, this is the type of information that we send. And the poster that we typically send out is what looks like on the left-hand side here, right? So that is the poster that the interesting parties can see. It could be law enforcement, it could be business owners, it could be gas stations, it could be any number of them. So anywhere where we think, the child is traveling, we inform that person so that, they have enough information to be able to respond back to us. Okay. Now, what we are challenging you with this exercise is, if you see, this is the type of information that goes out currently. What is really missing potentially is this information. This is something that I added right now for this presentation, right? So go back. So the idea is to see if we can come up with some sort of a risk score based on the data sets that we will provide you. For example, it might not necessarily be that, but we are trying to put out some ideas out there, right? So an idea is to see if we can come up with, okay, what is the entire risk for this child who goes missing in this area? So if you're looking at the child that went missing in the DeKalb area, and if you see criminal activity in that area at a very holistic level, what is the risk to this child in that area, right? And see if you can come up with some information. What we have put out as an example of a score, which the higher the score, the more troublesome the scenario is, and it will enforce to the law enforcement that they need to act very quickly and provide them a little more information in addition to the score, why the score was arrived at, so that they can go and target those people and come up with solutions, if that makes sense. Okay, so that's the critical nature of what we're trying to do in this challenge. So to summarize the challenge, again, there's over 26,000 runaways reported to NECMEC in 2020. 1 in 6 were likely victims of child sex trafficking. How do we reduce this number drastically so that we can empower the law enforcement officers with more information by solving some of the things that we want to solve during this challenge is the key. So what will we provide you as far as this challenge is concerned? Well, we have several data sets. I think the most important data sets for you to be worried about is the Georgia Sex Offender Database that contains all the sex offenders that have been currently identified in the Georgia area. Oh, one other thing I want to point out, we want to restrict this use case that you're solving to Georgia, just because I think looking at it at a single state level will give you a much more granular detail of what is going on than try to look at it at a country level. If you're able to solve it at the state level, then we can easily extend that and make it happen at the country level. So that's kind of what we are thinking. But as I said, this is a hackathon, and we give you the flexibility to go out of the box and bring in your ideas as well. So that's one database that we provide. The other database is, as of January 2021, who are the kids that were reported missing in Georgia? So you can make the left-hand side and the right-hand side work together, right? So that's the key. So we're looking at Georgia, and we're looking at sex offenders in Georgia. We're looking at kids reported missing in Georgia during a certain period, and see how we can bring it all together. Okay. Now, the other important thing that you will need, obviously, is the lat-long information, because quite a lot of this analysis is going to be location specific, right? If the child goes missing in this location, what is the risk? And to be able to do that, you'll have to triangulate a radius, 10 miles, 20 miles, 30 miles, 100 miles, whatever that radius is, and come up with various risk scenarios. And within that radius, you'll have to consider who are the criminals residing in those areas, and then come up with concepts of how you can help locate this child. If that makes sense. Okay. And then we provide you the tools. Obviously, HPCC systems, one of the leading edge tools in the world for doing any type of data processing. And I think these tools that we provide is going to be extremely helpful to you. And one of the key things that you're going to do is curate this data, in the sense that you're going to bring in the data and do some sort of cleaning and standardization before you bring it all together. Typically in the industry, we call it ETL, and that is what HPCC is fantastic at doing. It really abstracts the whole process of going through your record and then extract and transform information. So you love working with HPCC. And then we have a nicely integrated cloud IDE environment, which that way you don't have to install anything and struggle with installation before you get going. So I think that'll be a very good experience for you too. Okay, and last but not least, we have a fantastic set of very senior mentors who have extremely good technology experience for the last, I think, more than 10 years in the big data analytics world. So, and all have been in the LexisNexis fold for close to 10 years, if not more. Okay. Then the getting started tutorial, you must already have access to it, but if you have not seen this, you need to go there, because it contains tremendous amount of information that Bahar and the rest of the team have put together, which walks you through literally each and every step of getting this environment set up and working, and also providing some examples of code that you could potentially use in your challenge. Finally, I want to talk about the presentation that Trish McCall is going to be doing on Tuesday the 23rd. As I was talking about the ADAM program, I deliberately only talked about it at a very high level, mainly because Trish is going to dive deep into the program itself, show you some demos, show you some videos. So that is going to be a very impactful presentation. So tune in on Tuesday the 23rd at 4 p.m. to see this presentation. Now we are hosting the QA session, so this is what we recorded yesterday. So if you have any questions now, feel free to ask questions. That's all I have. Okay.
So there is a question in the chat. It looks like Neil is wanting to know how they would get the area radius from the missing child's location.
Perfect. Dan, do you want to take that?
I was actually looking up, I saw the question. I was going to look up the appropriate answer to make sure you use the right jargon. But the easiest way to do that it's to search for distance calculations with latitude, longitude. If you search for that, you'll find there's a fairly simple equation that'll give you a conversion rate from, or the distance between two lat-long coordinates, or you can do a radius. To be honest with you, instead of doing a perfect circle, it's a lot easier to do squares. So given a lat-long coordinate, you can kind of figure out, given a certain distance, what is the northmost, southmost, westmost, and eastmost boundaries, and then compute a square or a rectangle. Then you can search within that.
Got you. I had another question. Is that you mentioned in your, I don't know if you said that during the meeting today, but in the YouTube video, I think Arjun mentioned that we should use some kind of weighted mechanism to figure out who is like on a higher list. How do you suggest that weighted mechanism should work? I just want to get in like a starting point for that.
Yeah, I can throw you some hints, right? So one of the criteria that you definitely want to consider is the age of the child, right? So if the child is of a certain age and based on the circumstances that has been described and how the child went missing, the risk can be significantly higher, right? So take an example. So if a 11-year-old child goes missing versus a 16-year-old child missing, there's a different set of risk that is involved, correct? So that is one criteria that you want to consider, the age of the child. Then gender of the child could be other criteria that might help you, right? If the child is male versus female, the risks might differ, if they go missing in a certain area. So that's depending upon the type of criminals that you find in that area. When you look at the criminal database, what were they really charged for? And based on that, the rating on your scale either goes up or goes down, right? Then you also want to take into consideration the type of criminals, as I was just describing, in that area itself. So if you're marking out a square or a radius and you find some very highly notorious type of people in that area who have a lengthy record, then you want to consider that, and that becomes a very problematic scenario for law enforcement. So the risk score goes up there as well, right? So, but if it is not that high risk, then you want to consider bringing down that risk score. So those are some of the hints that I can provide you, but I'm sure there's so much more, ideas out there that you can use. What is, for example, we haven't provided the data set. You could probably use how does poverty or socioeconomic factors influence where the child goes missing, and and then you could also look at what was the historic trend of child going missing in these certain areas. So a lot of things that you can do and expand on, but I gave you some ideas hopefully on what you could use to actually calculate that.
Gotcha. Thank you.
Great questions. Any other questions? Any other questions on the technology side, for example, HPCC, ECL? Any questions like that? Are you comfortable, uncomfortable with it? How can we help you get started very quickly?
I have a question. That is like when we're working on it, if we have questions, how can we get in touch with one of you guys?
Oh, absolutely. Bart, do you want to take that?
Sure. So mentors are available to answer questions starting Monday from 9 a.m. to 9 p.m. There is an HPCC channel on Discord, so all you need to do is post your questions there, and then one of the mentors will get back to you in a timely manner. So, but keep in mind that we start Monday morning at 9 a.m., then we'll stop helping at 9 p.m.
Neil, let me ask you, do you have the Discord access? Are you a member already there?
I have not joined the Discord channel yet. I'll join it soon.
Oh, awesome. Okay.
Adriana just shared the link in the channel, in the chat side. Thank you, Adriana.
I have a question.
Sure.
I'm wondering, can our solution include like private owned companies like Ring Camera if I wanted to like have like users like and send an email to like Ring Camera users to like try to access like locate missing children in the area?
So let me see. So are you asking if the private company can register to receive emails for missing children?
Like
right?
like kind of like partnering or something, like, or would that be like too out of scope?
No, I mean, that feature is already there in the Adam program. So one of the features in Adam program is, again, Trish is going to talk about it, is that there is a registration process for any private business or any person who's interested. You could be you, me, or anybody who's interested in getting alerts of missing children. You can register there. And then once we do have the information about the missing child, we then project that information out to all people who are interested in this.
Okay, thank you.
Sure. So any of you, have you started at least introspecting what you have to do? Do you have any ideas and approaches of how you're going to solve the problem? Probably too early.
Yeah, me and my group hasn't had the chance to talk about it yet.
Yeah.
I just want to make one point looking at the ECF watch and the jobs you started to run. If it's a module, it's not runnable. So in order to see the data, you need to start with outputting the view data sets. So if it says a module on the top and it's part of the README file, so it's already mentioned, if you go to the README portion of the workspace, it will tell you if it's a module, you can't run it. If that helps any of the students trying to get the workspace set up and ready.
Yeah, ECL is actually fairly easy if you understand the concepts of data processing. You'll soon realize that when you actually ingest the data and start working with the data, quite a lot of effort is going to be in actually making sure the data is clean, number one, and then standardizing it to some layout where you can then use it for your analysis. So that's number two. These are literally the first two critical operations that anybody who's using big data skills or big data platforms will do. And what ECL provides you is, the different looping techniques or iteration techniques that you can go through all these record sets and either convert one record at a time or group a set of records and convert the group of records to something. Or you want to only work with a couple of records at a time and convert those couple of records to something. So it gives you all these abstractions so that you can do this very, very easily. So you just have to decide what is that pattern that you're going to use to actually manipulate the data. And then once you have that in your mind, okay, now how do I apply this in HPCC ECL? And you can do that.
Chantal, I see you've asked if you'll have access to this session's recording. You will. So the recording will be posted on our CCSE YouTube channel. I'll also post a link in the Discord server. So if you're not already a member there, I would say go ahead and join. And then I believe it will also be located on the Hackathon website. So there will be a few different spots where you can access the recording.
Okay, thank you.
So I'm wondering, do y'all already have any like functionality that looks into a child's social media to like analyze it?
Not that I can recall, no, but that'll be an interesting addition for sure. It's a very good idea, actually. So if you do have some data set that we can potentially ingest into this use case, feel free to suggest that. But at the end of it, we need it in the format of like a data set, right? And then we can integrate some of that. But you're right. In many cases, there might be chatter on social media that might be very helpful to law enforcement, and that will help in the creation of a risk score as well. That's a fantastic idea. If I'm thinking about it, just because mostly criminal organizations, they do have the habit of actually chatting using social media, and if we are able to pick up on the chat and then connect the dots to the people on the ground, then you will have a fairly powerful solution.
Okay, awesome. Thank you.
So yeah, I think as far as the challenge, there's so much you can do about this, and one of the ideas that you just suggested is, to me, it is a lot more involved, right? In the sense, now you not only have to bring down that social media data, but you need to do some semantic analysis of the chatter itself to understand what is the tone of the chatter and does it really relate to something that has happened on the ground. And based on that, you can connect the dots. So it is, I feel like a great project for maybe an internship or in a future product within LexisNexis, either way. So keep being involved. The other thing that I would suggest is, for this hackathon, make sure your scope is pretty well defined, because you can run away with many ideas, and not achieve what you want to achieve by the end of the day as far as the hackathon is concerned. So keep that in mind when you approach the problem. By the way, we have all these mentors that you're going to be interacting with at some point or time. They've worked on live projects that involve data somehow related to these types of data sets. Right? It might not be with regard to missing children per se, but it might be with regard to fraudsters, for example, and identifying fraud. So all the mentors have been involved in some ways or fashion in working with these types of data sets. So if you have any ideas, if you have anything, any suggestions to incorporate in either into your challenge or into your future project product with LexisNexis, we are open to those ideas. So feel free to reach out to us. So Bhar, do we conclude now? If there are any no more questions, or do we wait, or what is the process?
I think that's Adriana's decision.
So we can go ahead and conclude now. Dawn and I will stay in the meeting just in case anyone pops in the last few minutes and let them know where they can access the recording.
Yeah, that'll be fantastic. I mean, we can stay if you want to, but I guess if most of them come in, probably they won't have the context. They probably have to see the video and then build that context. But